Hello. In the previous video, we talked about the charge and the electric current, and we said that we will have a current if we have a flow of charges. And we talked about two basic types of materials, insulators and conductors. Within insulators, we might have static charge on top of it, but no charge will move, and therefore we don't have any electric current through insulator. On the other hand, with a conductor, we're gonna have charge moving through the conductor, and therefore conductor will conduct current. But there is one important characteristic of every element, either conductor or insulator. Not all conductors are the same, not all insulators are the same. Each object will be characterized by what we call the resistance. So every object has some sort of resistance to the flow of the current. Conductors usually and typically will have small resistance to the flow of current. On the other hand, insulators will have a very large resistance, and that's why we don't have electricity running through insulators. So in this video, I'd like to intuitively illustrate the resistance and the relationship between current and resistance. To do so, we're gonna have a physical analogy from a straw, a drinking straw. Okay, so within the straw there might be some air molecules moving freely, but the net movement of these air molecules are zero. So the analogy, we have our charge Q as analogous to air molecules. Now, if we blow through the straw, we're gonna have an airflow rate, and we're gonna have an output airflow. So the current is equivalent to the airflow in our analogy here. Now, in order for us to have some output flow rate here, this doesn't happen alone. Instead, we need to apply some pressure. So this pressure is the force that will cause air to flow. In electricity, this pressure is equivalent to what we call voltage, and this is what we come from an electric battery or a power supply. So in order for us to power an electric lamp, we need a power supply. So we need some voltage supply that apply the power. So we have a voltage drop, and therefore this will cause charge to move. Okay, now think about what happens if you are putting higher pressure on your straw here. Yes, we're gonna have more flow of air. So going back to the electricity analogy, more pressure means that we have high voltage, voltage V. So as we increase the voltage, the flow rate of air molecules, or in electricity, the flow rate of electric charge will increase. Therefore, the current will increase. Okay, so I is for current, V is for voltage. Okay. Now, let's imagine another scenario. So we are applying the same pressure in both scenarios. So here we fixed our voltage if you are talking about an electric circuit. In one scenario, we have a longer tube. In the second scenario, we have a shorter tube, and actually we have two tubes. What is the observed flow rate at the output? Which one will have higher flow rate? Situation 1 or situation 2? Yes, situation 2 will allow more flow rate. So here I'm not talking about the voltage coming from the battery. Actually, I'm talking about the characteristics of the straw itself. The straw here can be analogous to our conductor. So if the length of the conductor increase, the flow rate, and as a result the current will decrease. We don't have that much flow rate. On the other hand, if I increase the area of my conductor, I'm going to observe more flow rate, more current for the same length. So now, if we apply the same pressure, so apply the same voltage, we have the same battery or the power supply, we would like to observe the output airflow, or in analogy to the current, we have different things. The surface area, so is the cross-sectional area of the straw, i.e. our conductor, and the length of our conductor. As I increase the area, we're gonna have more air coming out, and as I increase the length of the conductor, we're gonna have less air coming out, and this will describe the resistivity of this straw. So in general, a resistivity of an electric element is described by this equation. The resistivity depends on the length of the conductor and inversely proportional to the surface area, and is proportional to what we call the resistivity of the conducting material. Then we have our electric current, which is equivalent to the airflow rate. The current is proportional with the voltage, so as I apply more voltage, we're gonna get more current. But if I increase the resistance, we're gonna have less current coming out of this conductor. Increasing the resistance is equivalent to reducing the area or increasing the length of our conductor. So in an electric circuit relationship, we have a relationship between the voltage, which is the power, like the main component of the power, current, and resistance. The current, voltage, and resistor are combined by what we call Ohm's law. V is equal to IR, or more precisely, you can see that I is equal to V over R. The current is directly proportional to the voltage applied to your circuit element and inversely proportional to the resistance of that element. This resistance has units of ohms, and the resistance describe the resistance of an element to the flow of electrons through it. Elements with very small resistance will allow more current to pass through it, and this would be a conductor. And elements with a very, very large resistance doesn't allow charge to go through it, and therefore we don't have any current due to this high resistivity. Thank you.